Nernst equation is a relationship between EMF and concentration of metal ions. First, we are going to derive relationship between free energy and EMF of a cell. Friends, as you know, free energy is nothing but available energy which is required to do work. And here our work is to generate electricity. Now here let us suppose that n is a number of electrons involved in a cell reaction. If reaction is Ag, it gives Ag positive plus electron. Then in this cell reaction, number of electron is 1. Whereas if reaction is like this, that Zn, it gives Zn2 positive plus 2 electron. Then number of electrons involved in a cell reaction are 2. Whereas if Al, it is deep in its salt solution, Al3 positive, then reaction may be like this, that Al, it gives Al3 positive plus 3 electrons. So in this cell reaction, number of electrons are 3. So let us suppose that n is a number of electrons involved in a cell reaction. And F is a Faraday's electricity produced per electron. So for one electron, if Faraday's electricity is F, then for n electron, it is Nf. So electricity produced is Nf. Now electrical energy is nothing but product of electricity produced and EMF of cell. So in this way, electrical energy is equal to N into F into E. Now according to Gibbs, decrease in free energy is equal to electrical energy. Now as you know, delta G is nothing but free energy, that is energy available to do work. And here work is to generate electricity. तो क्या होगा, जैसे जैसे इलेक्ट्रिसिटी जनरेट होगी, फ्री एनर्जी जो है वो कम होती जाएगी. That's why here minus delta G is equal to NFE. This is the relationship. Now if temperature is 25 degrees centigrade and concentration of salt solution is 1 molar, then free energy, it is called as standard free energy. Similarly, EMF, it is also known as standard EMF. Here note that number of electrons and value of F remains constant, because if Zn, it gives Zn2 positive plus 2 electron. Whatever may be the temperature and concentration of salt solution, number of electrons involved in cell reaction are 2. So that's why N and similarly F remains constant. So relation for standard free energy change is like this, that minus delta G0 is equal to NFE0. Now let us consider general cell reaction AA plus BB, it gives MM plus NN, where small a, b, m and n, these are the number of moles of the reactants and products. So A plus B, that is nothing but number of moles of reactant, and similarly M plus N, that is nothing but number of moles of product. Now according to Ventop isotherm, as you know, it is a thermodynamic term. So change in free energy is given by delta G is equal to delta G0 plus RT ln Kp, where Kp is nothing but concentration of product divided by concentration of reactant. So this equation becomes delta G is equal to delta G0 plus RT ln concentration of product divided by concentration of reactant. Now here this is product side and this one is reactant side. So this relation becomes delta G is equal to delta G0 plus RT ln concentration of m raised to power small n into concentration of n raised to power small n divided by concentration of A raised to power small a and concentration of B raised to power small b. Now put value of delta G and delta G0 in above equation. As you know, delta G is equal to minus NFE and delta G0 is equal to minus NFE0. So put this value, this equation becomes like this. Then divided both the side by minus NF. So this relation becomes like this. By rearranging this equation, we get E is equal to E0 minus RT upon NF ln concentration of product divided by concentration of reactant. Now, if ln is replaced by log, then you have to multiply it by 2.303. So this relation becomes E is equal to E0 minus 2.303 RT upon NF log to the base 10 concentration of m raised to power m into concentration of n raised to power n divided by concentration of A raised to power A into concentration of B raised to power B. At 25 degrees centigrade, that is T is equal to 273 plus 25 degree Kelvin. R is equal to 8.313 joule, F is equal to 96500, and value of T, as I told you, 25 plus 273 degree Kelvin. Put all these value, so you get relation E is equal to E0 minus 0.0591 upon n log to the base 10 concentration of m raised to power m into concentration of n raised to power n divided by concentration of A raised to power small a into concentration of B raised to power small p. This equation is known as Nernst equation at 25 degrees centigrade. So in this way, this equation 1 and 2 are known as a Nernst equation. Now let's derive Nernst equation for half cell. As you know, on half cell, either oxidation or reduction reaction occurs. As you know, potential developed due to oxidation reaction is known as oxidation potential. Now suppose that metal rod M is deep in Mn positive solution. So here oxidation reaction occurs as M, it gives Mn positive plus n electron. It is similar to Zn, it gives Zn2 positive plus 2 electron. That means here metal is zinc, whereas number of electrons are 2. Now Nernst equation for oxidation potential or oxidation reaction is given as E oxidation is equal to E0 oxidation minus RT upon NF log now concentration of product divided by concentration of reactant. So instead of concentration, here we are taking activity. As you know, activity means nothing but product of concentration and activity coefficient. Now as you know, this is product side and this is reactant side. That's why here it is Am raised to power n positive divided by Am. But since Am, that is activity of metal, is nothing but for pure metal and it is considered as 1. So here E oxidation becomes E oxidation is equal to E0 minus RT upon NF ln Amn positive. If we take example of zinc, that means zinc rod deep in Zn2 positive solution, then for this the Nernst equation is written like this. If this ln is replaced by log, then this equation becomes potential of zinc is equal to standard EMF of zinc minus 2.303 RT upon 2F log to the base 10 activity of Zn2 positive ion. Whereas at 25 degrees centigrade, this equation becomes E oxidation potential of zinc is equal to E0 oxidation potential of zinc minus 0.0591 upon 2 log to the base 10 activity of Zn2 positive ion. Now let us derive Nernst equation for half cell for reduction reaction. As you know, potential produced due to reduction reaction is known as reduction potential. Suppose that copper rod is deep in CuSO4 solution. Then reduction reaction, that is nothing but gain of electron, is written as Cu2 positive plus 2 electron, it gives Cu. Now again use Nernst equation. So here this is product side and this one is reactant side. Again concentration of copper is considered as 1. So this equation becomes E reduction copper is equal to E0 reduction copper minus 0.0591 upon 2 log to the base 10 1 upon activity of Cu2 positive ion. Since here we take 0.0591, that means this is Nernst equation at 25 degrees centigrade. Now let's derive Nernst equation for a complete cell. So complete cell, as you know, zinc rod deep in ZnSO4 solution, this is one half cell, and copper rod deep in CuSO4 solution, this is second half cell. Solutions are connected by means of salt bridge, whereas metal rods are connected by means of potentiometer. So this is a complete cell. Now total cell potential is obtained by adding oxidation potential on left hand side electrode and reduction potential on right hand side electrode. So this equation becomes E cell is equal to E oxidation plus E reduction. So E cell written as E cell is equal to E oxidation zinc plus E reduction Cu. As you know, on left hand side electrode oxidation reaction takes place, whereas on right hand side reduction reaction takes place. Now put value of E zinc and E copper from the equation which are derived in the previous slides. So you get E cell is equal to E0 zinc plus E0 copper minus 2.303 RT upon 2F log to the base 10 activity of Zn2 positive ion divided by activity of Cu2 positive ion. As you know, E is equal to E Zn plus ECu. So for this E0, relation is like this, that E0 is equal to E0 zinc plus E0 copper. So instead of E0 zinc plus E0 copper, we can write E0 cell. So this equation becomes E cell is equal to E0 cell minus 0.0591 upon 2 log to the base 10 activity of Zn2 positive ion divided by activity of Cu2 positive ions. So this equation is for Daniell cell. If we consider general cell reaction at small a plus small b into capital B, it gives Cc plus Dt. So here this small a, b, c, d, these are the number of moles. So Nernst equation for this general type of reaction is written as E cell is equal to E0 cell minus 0.0591 upon n log to the base 10 concentration of C raised to power C into concentration of D raised to power D divided by concentration of A raised to power A into concentration of B raised to power B. So this is all about Nernst equation for half cell and complete cell. Thank you for watching this video.